In section 5-4, we're going to go back to Algebra 1, and you're going to be able to remember some of the ways to divide polynomials. Now, what the book did for you is they give you two nice examples. They give you a long division example just with regular numbers, just to kind of jog your memory as to how to divide. And then, if you do remember from Algebra 1, this is called polynomial long division. I'm going to walk you through this one. I'm going to assume that maybe you forget just a little bit. If you don't, that's great. But if you do forget, I'm going to teach you how to do long division. What we're going to do with these is, after we do the long division, we're going to talk about what it means to be a factor, one item of another. Okay? So let's just go to problem 1 and jog your memory back to Algebra 1. Long division. Use polynomial long division to take 4x squared plus 23x minus 16 and divide by x plus 5. So we're going to set it up. You put x plus 5 on the outside, and you put what you want to divide it, you want to put like your divisor over here. Now, in order to do this, go back to Algebra 1, let's think. How could x become a 4x squared? And if you want to write that question down, it might be a good idea. How does x become 4x squared? You multiply it by 4x. Okay, I'm going to actually write that down. How does x become 4x squared? Okay, and that is how I got 4x. How does x become 4x squared? Okay. Now we backwards distribute. Ready? So we do 4 times x, and you get 4x squared. Then you do 4 times 5, and you get plus 20x. So you backwards distribute, and now we change our sign. Because remember how, just back from Algebra 1, you change your sign whenever you subtract for your division. So this becomes a minus now, and this becomes a minus now. These two will now cancel, and you get a positive 3x minus 16. Now you ask yourself, how does x become 3x? You put your answer up here. It would become 3x if you multiplied by a positive 3. You're always concerned with this out front and the first term of what you're working on. So we backwards distribute. And here we go. So 3 times x is 3x. 3 times 5 is plus 15. And now, just like you would in regular division, you have to change your signs. So we get minus 3 and minus 15. You end up canceling these, and you get negative 31 as your remainder. Now, the reason it's your remainder is because x can never fit into negative 31. So it says, what is the quotient? We're going to answer our question over here. What is the quotient? The quotient is 4x plus 3, and the remainder is negative 31. Now you might ask, is there a way that I can check this? Absolutely. To check this, you take your original x plus 5, you FOIL it with 4x plus 3, and then after you FOIL, you take away 31. So you would get 4x squared plus 3x plus 20x plus 15, and then the minus 31 on the back. And then you combine your like terms, and you get 4x squared plus 23x minus 16. And you can see that was the original, so we did it right. Okay, let's try this. I think one more time. Nope, it's a got it. So we'll do the got it in class, and we'll just move down to this key concept box. Key concepts. What they're saying is that you can do what we just did. Okay, you do division. This is long division, just like we just did. Okay, if you do long division, And, so let's go ahead and write this math language and regular language. If you do long division, okay, and the remainder is 0, then you have perfect factors. Okay? And that's what it means by that. All of that language up there says is if you do long division, you get a remainder of 0, then you have perfect factors, one of the other. Let's move on. Problem 2, checking factors. Whenever the directions say to check factors, you just do long division and you want to see if there is a remainder. Alright, so we say x squared plus 1, is it a factor of this item? Now I need to put a big star here, and I want you to see that we are missing the x term. And I'm going to show you what to do with that, okay? Put x squared plus 1 out front, put your division bar. Now I want you to do 3x to the 4th minus 4x to the 3rd plus 12x squared. Now watch this. This is what happens when you're missing an x term. You ready? Plus 0x plus 5. You always want to put in something if you're missing it. Now ask yourself, what does x squared need to become 3x to the 4th? Well, it would need a 3 and it needs another x squared. Okay? So if you want to write that question down, the question was, what does x squared need to become 3x to the 4th? And that's how I got this 3x squared answer. Okay? Now we're going to backwards distribute. Ready? So we get 3x squared times x squared is 3x to the 4th. 3x squared times 1 actually goes under the square over here, okay? You move all the way over, and you get plus 3x squared. You want to line them up. Now we change our signs. I'm going to write change signs after lining up. Ready? So I wrote change signs after lining up. So a minus and a minus. These cancel. And 12 minus, well, let's bring stuff down. You bring down the minus 4x cubed. And then 12 minus 3x squared is 9x squared. Plus the 0x plus the 5. Now, you go again and you ask yourself, what does x squared need to become negative 4x cubed? Okay. Well, we know that it needs a negative sign, a 4, and another x. Okay. So we'll backwards distribute. So negative 4x times x squared is negative 4x cubed. Negative 4x times 1 is minus 4x. Okay, don't forget to line them up. So I change my signs. And this becomes a positive, this becomes a positive. Cancel, cancel. 9x squared plus 4x plus 5. Now I ask myself, what does x squared need to become 9x squared? So there's my new question. What does x squared need to become 9x squared? Well, it needs a positive 9. So I write that up there, and now I backwards distribute. So I get plus 9x squared plus a positive 9. Make sure you line them up. Put that on there, line up. Now we change our sign. You definitely don't have to write these directions down, but it's helpful when you go back and study them. These cancel. You bring down the 4x minus 9. Excuse me, minus 4 when you add them. Now, you should here understand that x squared does not go into 4x, so you're done. And you see this big ugly thing? That's the remainder. So here's what we're going to say. It says, is it a factor? It's really just a yes-no question. See how it says, is it a factor? We're going to say that x squared plus 1 is not a factor because when we divide, we get a remainder. So the answer is no. It's not a factor because when we divide, we get a remainder. Part B. Let's check if in part B we'll have a remainder. I'm not going to write down all the directions this time. I'm just going to do the problem. So you put x minus 2 on the outside. Now if we're missing anything, we have to put it as 0. So we'll do x to the 5th plus 0x to the 4th plus 0x to the 3rd plus 0x squared plus 0x minus 32. And it's an important step to put all of those zeros in there. X needs an x to the 4th to become x to the 5th. Backwards distribute, get x to the 5th minus 2x to the 4th. Change your signs and add. These cancel. You get 2x to the 4th plus 0x cubed plus 0x squared, just bringing stuff down, plus 0x minus 32. Okay, what does x need to become 2x to the 4th? It needs a 2 and an x cubed. Now backwards distribute, 2x to the 4th minus 2x cubed. Now change your signs and bring everything down. Did I multiply? I did not multiply. Okay, this should be a 4 right here. Because 2 times 2. Alright, cancel out. You get positive 4x cubed plus 0x squared plus 0x minus 32 when you bring items down. X needs a 4 and an x squared to go into 4x cubed. Backwards distribute, 4x cubed minus 8x squared. Change your signs. You get 8x squared plus 0x minus 32. Now, what does x need to be an 8? X squared, it needs an 8 and an x. Backwards distribute. 8x squared minus 16x. Change your signs. These cancel. 16x minus 32. Now, one more time. What does x need? What does x need to be a 16x? It needs a plus 16. Backwards distribute. You get 16x minus 32. You change your signs. And you get everything to cancel out. You get a remainder of 0. That's good. We want a remainder of 0. So what we're going to say, it says, is it a factor? Is x minus 2 a factor? We're going to say, yes. X minus 2 is a factor of x to the 5th minus 32 because the remainder is 0. And that's how you check for factors.